Welcome back to my channel. Today I am going to explain factors affecting on equilibrium constant. Factors affecting on equilibrium constant. Equilibrium constant denoted with capital K. Four factors affect to equilibrium constant. They are temperature, second is mode of writing, mode of writing or mode of representation, mode of representation of reaction, mode of representation of reaction. Third one, multi-step reaction. Fourth one, stoichiometry of the reaction. Okay, I will explain one by one. First one, temperature effect on equilibrium constant. Effect of temperature. Effect of temperature. So the effect of temperature on equilibrium constant could explained by want of equation. The effect of temperature on equilibrium constant could explained by the effect of temperature on K equilibrium constant explained by want of equation. Want of equation. What is want of equation? Log K2 by K1 is equals to delta H by enthalpy change of reaction by 2.303 capital R universal gas constant into 1 by T1 minus 1 by T2. Or this equation can also written as log K2 minus log K1 is equals to delta H by 2.303 R into T1 T2 LCM T1 T2. So this is T2 minus T1. So in these two cases, for exothermic reactions, effect of temperature on equilibrium constant. For exothermic reaction, effect of temperature on equilibrium constant. So for exothermic reaction, delta H is positive. That means this total term become positive. So in this case, delta H is what? Positive, and then the total term become positive. If T2 is greater than T1, if T2 greater than T1, then if T2 greater than T1, what happen? If T2 greater than T1, this term also become positive. That means then what happen? Log K2 minus log K1 become positive. Log K2 minus K1 become positive. That means K2 greater than K1. What does it mean? If T2 greater than T1, K2 greater than K1. It means for exothermic reaction, for exothermic reaction, for exothermic reaction, sorry, for exothermic reaction, కాదు ఇది small correction, for endothermic reaction. For endothermic reaction, delta H is positive kada. Yes. For endothermic reaction, when temperature increases, K value increases. When temperature increases, K value increases. Now case 2, for exothermic reaction. For exothermic reaction, delta H is equal to what? Negative. Delta H negative means this term become negative. And if T2 greater than T1, then what happen? T2 greater than T1 means this term become positive. Plus into minus, minus. That means what? This is plus, this is minus. Plus into minus, minus aitadi. Then what we can write? Then log K2 minus log K1 is negative. That means low value minus high value negative avutadi. So K2 less than K1. See here, if T2 greater than T1, K2 less than K1. From this what we can write? For exothermic reaction, when temperature increases, T2, K2 is less, so K value decreases. Temperature increases, K value decreases. Remember, for endothermic reaction, when temperature increases, K increases. For exothermic reaction, when temperature increases, K value decreases. Equilibrium constant decreases. This is what effect of temperature on equilibrium constant. Now second one, mode of representation of reaction. Mode of representation of reversible reaction. Second one is, second factor, mode of representation of reaction. For only reversible reaction, we talk equilibrium constant. So consider a reaction. A plus B are reactant. They gives C and D. It is reversible reaction and present at equilibrium state. At equilibrium state, what is equilibrium constant for this reaction? Equilibrium constant is product of molar concentration of product by product of molar concentration of reactant. Okay. Consider it as equation 1. If equation 2 is C plus D gives rise to A plus B like this, your equation is reversed. Then equilibrium constant becomes when equation is reversed, then equilibrium constant becomes what? So for this equilibrium constant K2, and for the first one equilibrium constant consider K1. So for this K2 is what? Molar concentration of A into molar concentration of B by molar concentration of C into molar concentration of D. And 1 by K2 become what? 1 by K2 become molar concentration of C into molar concentration of D by molar concentration of A into molar concentration of B. K1 by K2 is equal to what? This term is what? K1. These two are same, no? CD by AB is equal to K1. So what you can write? K1. This is the relation between K1 and K2. That means whenever equation is opposite, looking to be opposite, then equilibrium constant become inverse. K1 is equals to 1 by K2 or K2 is equals to 1 by K1. K2 is equals to what? 1 by K1. Whenever equation is looking to be opposite, then equilibrium constant become inverse. Next, third factor, multi-step reaction. Third factor, multi-step reaction. Multi-step reaction. Third factor is multi-step reaction. Right. Consider a reversible reaction. Consider a reversible reaction. N plus O2, N plus half O2 gives rise to రివర్సిబుల్గా తీసుకుందాం. NO ప్లస్ NO2 gives rise to NO plus half O2 gas. This is one reaction. Okay. Consider it as equation 1. For this, K1 is equals to what? Molar concentration of NO into molar concentration of O2 power 1 by 2 by molar concentration of NO2. Consider equation 2, that is SO2 gas plus half O2 gas gives rise to SO3 gas. For this reaction, equilibrium constant is equal to molar concentration of SO3 by molar concentration of SO2 into molar concentration of O2 power 1 by 2. Okay. If the third equation is like this, NO plus NO2 plus SO2 gives rise to NO plus SO3. All are gases. If third equation is like this, for this equilibrium constant is K3, then what happens? So if you see, by adding these two equations, third equation obtained. So by adding equation 1, equation 2, how? So half O2 get cancelled. By adding these two equation addition, we get the third equation. So if the third equation is in the form of addition of 1 to equation, then equilibrium constant for the third equation become K1 into K2. Equations are added, but equilibrium constants are multiplied. Remember this. Okay. Next, factor number 4. Stoichiometry of the reaction. Factor number 4 is stoichiometry of the reaction. Stoichiometric coefficients can also affect equilibrium constant. Stoichiometry of reaction. See this? Consider a chemical reaction present at equilibrium state, that is NO2, NO plus of O2 gives rise to NO2, or multiply this equation with 2. You can also write like this: 2NO plus O2 gives rise to 2NO2. Okay, so consider this one. For this equation, what is the equilibrium constant? Equilibrium constant is equal to molar concentration of NO2 raised to power 2 by molar concentration of NO into molar concentration of O2. If above equation is multiplied with multiplied with 2, then what we get? 4NO gas plus 2O2 gas gives rise to 4NO2. Okay, for this equilibrium constant K2, and for first equation consider equilibrium constant K1. Then K2 is what? Molar concentration of NO2 raised to power 4 by molar concentration of NO into molar NO raised to power 4, molar concentration of O2 raised to power 2. Okay, what is the relation between K1 and K2? Relation between K1 and K2. So K1 square, if you write K1 square is become what? Molar concentration of NO2, okay, power 2 into 2, ఏమైతే 4 అవుతుంది, by molar concentration of NO 1 into 2, 2, molar concentration of O2 power 1, అది కూడా 2తో multiply చేస్తే that also become 2. So now K2 appears as K1 square. Then K1 is become what? K1 become K1 is equals to what? Under root of K2, or K1 is equals to what? K1 is equal to what? K2 power 1 by 2. See this, if equation is multiplied with 2, then K1 become K2 power 1 by 2. If equation is multiplied with n, if equation, any chemical equation is multiplied with n, ఎంతో మల్టిప్లై చేసామనుకోండి, 2తో మల్టిప్లై చేస్తే ఏమైంది? పవర్ 1 by 2 అయింది కదా. ఒకవేళ ఎంతో మల్టిప్లై చేస్తే ఏమవుతుంది? K1 is equal to what? See this, K2 is equal to this one, K K1 is equal to K2 is equal to what? This term is this one. These two terms are same. That means instead of writing this one, you can write this one. So K2 is equal to K1 square. K1 is equal to under root of K2. K1 is equal to K2 power 1 by 2 అవుతుంది. Okay. So that become K2 power 1 by n అవుతుంది. Whenever equation is multiplied with 2, then this relation. Okay. Whenever equation is divided by 2, then what happens? When equation is divided by 2, then this equation divided by 2. Sorry. When this equation is right, this is basic equation. Okay, this is K1. When equation multiplied by 2, we are getting second equation. For that relation is this one. For K2, K1, K2 relation I have given. When equation is, if above equation, that means first equation. This one, above equation means first equation. This is two equation. Above first equation is divided by 2. So first equation divided by 2 means 2 by 2 become 1. So NO plus, here 1 is present, 1 by 2. That means 1 by 2 O2 gives rise to what? Here 2 is there, 2 by 2 become 1. So NO2. If first equation is divided by 2, then what we get? This one. Okay. So for this, what is equilibrium constant? Consider it as K3. K3 is equal to what? Molar concentration of NO2 by molar concentration of NO into molar concentration of O2 power 1 by 2 అవుతుంది. Okay. Now what is the relation between this K1 and K3? Relation between K1 and K3. Okay. In previous, what we have done? Relation between K1 and K2. Now relation between K1 and K3. Okay. How do we get K1? If you write K3 square is equal to what? Molar concentration of NO2 power NO2 raised to power 2 by molar concentration of NO into molar concentration of O2 1 by 2 into 2. Square ante 1 by 2 into 2 అవుతుంది. 2 cancel అయితే 1 అవుతుంది. Okay, like this. That means what? This equation obtained by squaring K3. So by squaring this one. So from this, what we can write K1 is equal to K3 power 2. So that means if equation is divided by 2, we get power 2. If equation is divided by n, if equation is divided with 1 by n, divided with n, 2తో డివైడ్ చేస్తే పవర్ 2 వచ్చింది. ఒకవేళ nతో డివైడ్ చేస్తే ఏమయ్యేది? K1 is equal to K3 power n అవుతుంది. K3 power n. Okay, this is the relation. K1 is equal to K3 power n అవుతుంది. అంటే from this, what we can write? Stoichiometry. How does stoichiometry can affect equilibrium constant? If equation is multiplied with 2, then K1 is equals to K2 power of multiplied, it become power 1 by 2. If you multiply with n, it become power 1 by n. Whenever equation is multiplied, it become power 1 by that stoichiometric coefficient. If multiplied with 2, then it become power 1 by 2. If equation is multiplied with n, then it become power 1 by n. In this case, this is division. This is what? Division. So if equation is divided by 2, we get it is square k3 power 2. If equation is divided with n, it become power n. Divide చేస్తే పవర్ అవుతుంది, మల్టిప్లై చేస్తే పవర్ 1 by that value అవుతుంది అనమాట. Remember this thing. So thus 4 factors affect equilibrium constant. What are those 4 factors? See once. What are 4 factors? 4 factors. First one, temperature. First one is the temperature. Effect of temperature on equilibrium constant explained by want of equation. Okay, from this equation, effect of temperature for two types of reaction, for endothermic reaction and for exothermic reaction. For endothermic reaction, delta H negative, then this term become delta H is positive, this term become positive. If T2 greater than T1, this term also become positive. Now two terms positive means what happen? This term become positive. That means log K2 minus K1 is equals to positive. That means K2 greater than K1 అవుతుంది. If T2 greater than T1, K2 greater than K1. What does it mean? For exothermic reaction, when temperature increases, K value increases. For exothermic reaction, delta H is negative. For exothermic reaction, delta H negative means, so green color తో చూపిస్తున్నా చూడండి, delta H is negative. If T2 greater than T1, then what happens? This term become positive. So minus into plus become total, this term become negative. That means K2 less than K1. Lower value minus higher value become minus. So K2 less than K1 అవుతుంది. What does it mean? When temperature increases, for exothermic reaction, when temperature increases, T2 greater, T1 is K1, at T2 K2. That means when temperature increases, K value decreases. That's my point. Next, second thing, mode of representation of reversible reaction can also affect equilibrium constant. So for that, first I consider equation, reversible equation A plus B gives rise to C plus D, and this reaction should be at equilibrium constant. Then only we talk about equilibrium constant. So equilibrium constant for this reaction is molar concentration of C into molar concentration of D by molar concentration of A into molar concentration of B. If some other reaction appear like this, then for this reaction equilibrium constant become K2. Now what is my question? What is the relation between K1 and K2? Whenever equation is reversed, then equation like this. Equation is reversed, equilibrium constant become inverse. Next, third factor that affect equilibrium constant is multi-step reaction. So this equation appears as the sum of these two equations. And by adding these two equations, we are getting third equation. Then equilibrium constant should not add, equilibrium constant should multiply. Equations are added, equilibrium constant is multiplied. Remember this one. And fourth factor is stoichiometry of the reaction. Fourth factor is stoichiometry of the reaction. See this, whenever some equation, this is one equation, if second equation appear like this, how is this equation looking like? By multiplying first equation, we are getting second equation. Then equilibrium constant of first reaction is equilibrium constant of second reaction power 1 by 2 అయింది. అంటే 2 తోటి మల్టిప్లై చేస్తే 1 by 2 అయింది. ఇఫ్ ఈక్వేషన్ ఇది లుకింగ్ లైక్ మల్టిప్లయింగ్ విత్ ఎన్ అయితే అప్పుడు K1 is equal to K2 power 1 by n అవుతుంది. ఓకే రైట్. ఇఫ్ above equation is divided by 2, then what happen? If see like this is the third equation. This third equation appears as first equation divided by 2. ఈక్వేషన్ 2తో డివైడ్ చేస్తే ఈ ఈక్వేషన్ వచ్చినట్టుగా ఉంది. అంటే 2తో డివైడ్ చేస్తే ఫస్ట్ ఈక్వేషన్ 2తో డివైడ్ చేస్తే థర్డ్ ఈక్వేషన్ వచ్చింది. అప్పుడు ఈక్విలిబ్రియం కాన్స్టెంట్ ఏమవుతుంది? ఫస్ట్ ఈక్వేషన్ ఈక్విలిబ్రియం కాన్స్టెంట్ ఈజ్ ఈక్వల్ థర్డ్ ఈక్వేషన్ పవర్ n అయింది. అంటే 2తో డివైడ్ చేస్తే పవర్ 2 అయింది, nతో డివైడ్ చేస్తే పవర్ n అయింది. అంటే దేంతో డివైడ్ చేస్తే పవర్ ఆ స్టాయికియోమెట్రిక్ కోఎఫిషియంట్ అవుతుంది అనమాట. ఓకే, అంటే మల్టిప్లై చేస్తేనేమో పవర్ 1/something, డివైడ్ చేస్తేనేమో పవర్ సంథింగ్. ఓకే, సో దీస్ 4 are factors which affect equilibrium constant. Hope you understood. Next, there are 2 previous questions on this topic. 2 questions. Okay, this is the question which was asked in 2024 April 8th shift 1 JEE mains question paper. So this is hypothetical reaction. So xy represented in the form of English alphabet. Equilibrium constants are given for these 2 reactions. Now in this question equilibrium constant for this reaction was asked. So how do we get this equation, required equation, from equation 1, 2 and 3? See, so x and y gives rise to z, and z gives rise to what? W. Equation is like this kada. So our required equation is x gives rise to w. So this equation obtained by adding these 3 equations, by addition of these above 3 equations. How is it? See, if y are cancelled, z are cancelled, left to right cancel, then what we get? X gives rise to w. Then what we get? X gives rise to w అవుతుంది కదా. అంటే ఈక్వేషన్ 1, 2, 3 we need to add it. Whenever equation 1, 2, 3 we need to add, equilibrium constant for 1, 2, 3 should be multiplied kada. This is for this 1, and for this is 2, for this is 3. So if it is K4 అనుకుంటే ఏమవుతుంది? ఈ ఈక్వేషన్కి మనకి ఈక్విలిబ్రియం కాన్స్టెంట్ కావాలి. సో ఏమవుతుంది? దాన్ని K4 అనుకుంటే K4 is equal to, whenever equations are added, equilibrium constant should be multiply. అంటే K1 into K2 into K4 ఏవో మనం పైన చెప్పుకున్న ఈక్వేషన్ మల్టీ స్టెప్ రియాక్షన్ దగ్గర చెప్పుకున్నాం కదా, అట్లా. దెన్ ఇట్ బికమ్ 1 into 2 into 4. దెన్ K4 is equals to what? 8. So K4 is equal to 8 means which option is correct? Third option, C option is correct. Okay, next question. Right, question number 2 is equilibrium constant for some reaction given. Equilibrium constant for first reaction given, and asked to calculate value of equilibrium constant for this reaction. Now you need to write Kc for second reaction from Kc1. What is the relation between first equation and second equation? So second equation is reverse to first equation, first point. So if second equation is reversed, then what we get? 2SO3 gives rise to 2SO2 plus O2. So second equation is reversed, and divide equation with 2. Then what we get? Divide equation with 2. Then what we get? SO3 gas gives rise to SO2 plus 1/2. ఇక్కడ 1 ఉంది కదా, 1ని 2తో డివైడ్ చేసినాం, 2ని 2తో డివైడ్ చేస్తే 1, 2ని 2తో డివైడ్ చేస్తే 1. ఓకే, అంటే బై రైటింగ్ ఆపోజిట్ అండ్ బై డివైడింగ్ బై 2 we are getting equation 1. అంటే from this what we can write? So if it is K2, asked K2, and if it is K1 అయితే how is relation looking like? K1 or K2, anything, right? K2 is equals to ఏమవుతుంది 1/k1 స్క్వేర్ 1/k1 స్క్వేర్. ఎందుకని సెకండ్ ఈక్వేషన్ ఫస్ట్ ఈక్వేషన్కి రివర్స్ ఉంది కాబట్టి k2 ఈజ్ ఈక్వల్ టు 1/k1 అంటే సెకండ్ ఈక్వేషన్ ఫస్ట్ ఈక్వేషన్కి డివైడ్ చేసినట్టుగా ఉంది. డివైడ్ చేస్తే ఏమవుతుంది 2తో డివైడ్ చేశాను కాబట్టి పవర్ 2 అయింది. డివైడ్ చేస్తే పవర్ అవుతుంది, మల్టిప్లై చేస్తేనేమో పవర్ 1/, దట్ స్టాయికోమెట్రిక్ కోఎఫిషియంట్. అంటే ఎంతో మల్టిప్లై చేస్తే పవర్ 1/n అవుతుంది, ఎంతో డివైడ్ చేస్తే పవర్ n అవుతుంది. అంటే దేంతో డివైడ్ చేస్తామో అది పవర్ అవుతుంది. సో కాబట్టి 2తో డివైడ్ చేసాం కాబట్టి 2. అంటే ఈక్వేషన్ 2 ఎట్లుంది, ఈక్వేషన్ 1కి రివర్స్. అప్పుడు k2 ఏమవుతుంది k1 1/k1 అవుతుంది. ఈక్వేషన్ మనకు వచ్చిన ఈక్వేషన్ ఉంది కదా, డివైడ్ చేసి రివర్స్ రాసిన తర్వాత దాన్ని 2తో డివైడ్ చేయాలి. అంటే ఏం చేయాల్సి ఉంటుంది, మనం కంపల్సరీ ఇన్వర్స్ చేసి 2 స్క్వేర్ చేయాలన్నమాట. ఇట్ బికమ్ లైక్ సో k2 ఈజ్ ఈక్వల్ టు వాట్, k2 ఈజ్ ఈక్వల్ టు వాట్ అంటే 1/k1 వాల్యూ 4.9 ఇంటూ 10⁻² అవుతుంది. 10⁻² హోల్ పవర్ 2. సో k2 ఈజ్ ఈక్వల్ టు ఏమవుతుంది 1/4.9 ఇంటూ 4.9. సో ముందు ఓపెన్ చేయండి. దీన్ని ఏం చేయొచ్చు అంటే మనం రైట్ లైక్ దిస్ 4.9 ఇంటూ 4.9 ఏమవుతుందో చూడండి. సో ఐఎమ్ 4.9 ఇంటూ 4.9 ఏమవుతుంది 9 9s 81, 9 4s 36, 44 అండ్ 4 9s 36 అండ్ 4 4s 16 అంటే 19 అవుతుంది కదా. as this become 1 and this become 0 and this become 4 and this become 1. 14 point అలా ఎలా అవుతుంది 9 9s 81 ఓకే, 9 4s 36 plus 8 44 it's clear and 4 9s 36 okay, 4 4s 16 19 అవుతుంది 1 and this is become 10 and this is become 14 and it become 24. 24.01 ఇంటూ 10⁻² ఇంటూ 10⁻², 10⁻⁴ అవుతుంది కదా. సో k2 ఈజ్ ఈక్వల్ టు వాట్, k2 ఈజ్ ఈక్వల్ 10⁻⁴ పైకి పోతే 10⁻4 అవుతుంది. 10⁻4 10⁻4ని 10⁻2 ఇంటూ 10⁻2 అని రాసుకోవచ్చు. సో 10⁻2 ఇంటూ 10⁻2/24.01. if you multiply if you divide 100 with 24.01 it become first 4 times, then it become how much 96. The 4 remains point పెట్టుకుంటాం and 4 remains means 40 తోటి 24 1 time and 6 times అవుతుంది into 10⁻2. so k2 is equal to what 100 తోటి 4.16 మల్టిప్లై చేస్తే 416 అవుతుంది అనమాట. ఓకే, దీంట్లో ఏంటి k2కి k1కి రిలేషన్ ఎస్టాబ్లిష్ చేయడమే కీ పాయింట్ అనమాట ఇక్కడ. సో ఇప్పుడు ఈక్వేషన్ 2 ఎట్లా వస్తుంది ఈక్వేషన్ 1 నుంచి అంటే ఈక్వేషన్ 2 ఈక్వేషన్ 1కి రివర్స్ ఉంది. సో నేనేం చేశాను ఈక్వేషన్ 2ని రివర్స్ చేశాను. రివర్స్ చేస్తే ఈక్వేషన్ లైక్ దిస్, రివర్స్ చేస్తే ఈక్వేషన్ ఇలా ఉంది. తర్వాత ఏం చేశాను డివైడెడ్ బై 2. సో అంటే ఏమని రాయొచ్చు k2 ఈజ్ ఈక్వల్ అంటే k2 ఈజ్ ఈక్వల్ k1కి ఎట్లుంది రివర్స్ ఉంది అండ్ k1ని ఏం చేస్తే k2 వస్తుంది, k1ని ఏం చేస్తే k2 వస్తుంది, ఇది కదా k2, ఇది k1 కదా. k1 నుంచి k2 రావాలి అంటే k1 నుంచి ఇది k2 రివర్స్ చేసిన తర్వాత వచ్చింది కదా. సో ఇది రావాలంటే ఏం చేయాలంటే స్క్వేరింగ్ చేసినాం అనమాట. అంటే మనం ఎప్పుడైనా డివైడ్ చేస్తే పవర్ అవుతుంది, అది గుర్తుంచుకోండి. సో వీ గెట్ దిస్ వన్. విచ్ ఆప్షన్ ఈజ్ కరెక్ట్ అండి, ఆప్షన్ డి ఈజ్ కరెక్ట్. Which option is correct? Option D correct. Okay. Thank you for watching.